Hello, this is Brian Gomer, and welcome to another installment of the Spectrum Ownership Landscape. Today's installment, we're going to be focused on talking about the EBS-BRS spectrum gradients. EBS stands for Educational Broadcast Service, and BRS is Broadband Radio Service. Those are commonly in the U.S. referred to as the 2.5 gigahertz band. Before we jump into the tools that I've developed in that area, I just want to go through one legal statement around our intellectual property. All of the reports, formats, technical concepts, methods, procedures, and processes discussed in the following presentation are subject to a provisional patent that will be vigorously defended. And with that, we're going to go ahead and jump in and start to talk about the EBS-BRS spectrum. Okay. So what I'm displaying on the screen to start with is a spreadsheet that literally lists every county in the United States. And the reason, hopefully at this point you've already gone through some of the other presentations on a different spectrum product that I have, the Spectrum Ownership Landscape. The reason that this report is separate and needed to be pulled together is because contrary to most of the rest of the spectrum that the Spectrum Landscape report covers, the cellular 700 meg, AWS, PCS spectrum, all those spectrum bands are fairly complete where you're able to accurately represent a primary spectrum owner or controller at a county level, that the spectrum was auctioned, at some kind of a regional boundary, BTAs, MTAs, CMAs, where a county was a building block of kind of how that spectrum was allocated. The EBS-BRS spectrum has, because it really tied back to originally to video leases and video licenses, has much more geographic boundaries. It's really based upon a set of 35-mile circles, and they're bisected, and football splits, and a lot of different challenges like that. So it's much more difficult to really understand how far and how much population a particular license covers. So to get a accurate representation of the amount of coverage or the percentage of ownership essentially within a county, you have to go to what I call kind of a weighted POPs approach. So what I'll begin to kind of describe is what we arrive at is a cell in this data indicates, you'll see some cells here that in Bergen County, and this is all run for one carrier. This is for Clearwire. If you want to look at another EBS or BRS carrier, you have to kind of run them separately. The analysis is pretty intensive on the backside to arrive at how many POPs they cover with all their different licenses within any one of these markets. But I'm highlighting the fact that the BRS1 channel, the 100% here, the Clearwire controls all of the spectrum covering 100% of the POPs in that particular county. So essentially county to county border coverage. While the A1 channel, what I can notice is they don't appear to have signed a lease with whoever is licensed for that channel because neither the A1, A2, A3, or the A4, which is here in the video part of the band, have been leased to Clearwire, so it's not in Clearwire's control. To go to a different area of the spreadsheet, down here to Somerset County, you can see that Clearwire does control some ownership of some spectrum that's licensed in that county, so it's probably a portion of one of those 35-mile circles that intersects and goes over part of the county, and we're able to total up the number of the population that's covered by that portion of their license. And that portion of their license is basically 14% of that county's population. We'll scroll a little bit to the right here in a second, but in the same way that we constructed the spectrum ownership landscape, we created all of these filters of regions so that if you want to see Clearwire or any other EBS-BRS spectrum broken down by the MTA, all of this spectrum is actually licensed and auctioned. The unserved area has been auctioned as a BTA, so that's a framework that makes a lot of sense for the EBS-BRS spectrum. If you happen to want to see it with the REAG, EAG, MEA, EAs, those are all there. And again, I tend to still stay focused on the CMAs because that is really what I consider to be the spectrum-starved areas, the highest population areas of the United States, and then those target the specific counties that make up those highest population areas. So you can do any auto filtering here. If you wanted to look at Los Angeles, you can either pick it there by CMA number 2, or come over here and scroll down. It's always a good test for your remembering your alphabet. But then I can highlight what the Los Angeles area markets look like. I'm going to go ahead and bring my scroll bar in now so that we can begin to look at the data here. Get this all set up. There we go. So by looking at this data, what jumps out to us, that the first level of analysis that's I think important to look at is to try to understand for Clearwire how many of these 20 megahertz channels can Clearwire pull together in a particular market. And what using this weighted POPs approach, you can see that they have all of this contiguous spectrum in basically the owned spectrum, which is the E, F, and H block, which you can total up how many of those megahertz and how many 20 megahertz channels will fit in there, and then you can make some educated guesses based upon the rest of their spectrum positions. One thing, I'm going to quickly expand that particular row because the spectrum actually is broken into some blocks of spectrum are 6 and some of them are 5.5. So now that that's a little bit more apparent, you can see that it's essentially going to take 4 of these channels to make one 20 megahertz channel. So to look at, here's 4, so there's 120, there's another 20. And then you also need to remember that this portion of the band is the video band, that in most of those top 20 markets, the video band is still in use with 1, 2, 3 video channels. So it would be very difficult for Clearwire at this point in time to input any of the 20 megahertz channels here in the middle. But what this data does allow you to do is to make some assumptions at a cutoff point. Say 70% of, if I cover 70% or more of the covered POPs in a market, I could consider that it is available or it would be usable for a 20 megahertz channel deployment. So you should be able to go through and quantify the available spectrum for LTE TDD deployment. I'm going to go ahead and turn all the filters back on so you can see that the data is populated across all markets. The other piece that rolls out of this analysis is that it provides us with a way to summarize the megahertz pops at a county level. Here, that basically by taking the county population and the percentage of pops that each of these channels have, allows us to arrive at a megahertz pop valuation for Clearwire. And then as well, we also arrive at really a weighted megahertz pop calculation. This is different than the calculation that I have in the Spectrum Landscape Report, where the total megahertz is really a number that's based upon the primary spectrum holder in a county. It doesn't necessarily mean that they are licensed for more than 50% of the population, but they're just the major spectrum holder in a particular locale. The other piece that you can do with this, because on the far left-hand side of my data I have, I don't want to copy that. I have a column here called the FIPS data, and again, this allows you to associate any, and in our case what we want to associate is either the megahertz pops values or most likely the megahertz values on a county basis, so that I can map those and see whether there are any interesting findings for where Clearwire has spectrum, where they lack spectrum. So then we can flip over and essentially display a map. Alright, now we should have up on the screen a display of the Clearwire's total spectrum by county. So this is a map representation of the data, and then you're able to, on the map, within your GIS program, you can set each of the different thresholds. So if you actually wanted to know, well, what counties does Clearwire have 0, you could have 0 called out as a different color and highlight all the counties that Clearwire has 0 or less than 20 megahertz. And again, what still is critical in this is the amount of contiguous spectrum, because if Clearwire has channel A1 is 5 megahertz and then they have G4, those are two 5 megahertz channels that could be used for LTE, but there's no way that that can actually be combined to be a 10 megahertz channel, although you could do that with carrier aggregation that's coming out in a couple of years for LTE, but that's going to be fairly limited on how many channels within a band you're going to be able to combine, and it will be more important for Clearwire to combine multiple channels that are adjacent to each other into large LTE pipes. But again, the part of the value in displaying this geographical representation of Clearwire spectrum is so that you can again see the hotspots, which on this map are red, where Clearwire has 130 megahertz of spectrum or more, all the way up to 186, or the areas that are relatively light. And Clearwire spectrum is always very heavy as it relates to metropolitan areas where video systems operated traditionally, and it becomes lighter. In fact, it's almost limited to the spectrum that was able to be purchased at auction, the BRS spectrum, outside of those areas. And then there are some areas of Clearwire spectrum or Clearwire's map where there continue to be video operations predominantly in a market, and that the data operations are not feasible at this point in time. I think that brings us to the end of our EBS BRS spectrum introduction. Thank you again for listening.